Hi, welcome to Mommy's Academy. In this video, I'll be teaching you determinant of a matrix. If you have not watched our previous videos on matrix, please watch them so that you can understand this proceeding topic, determinant of a matrix. We've learned that matrices are arranged in row and column, containing elements that are arranged in row and column. So let's see how determinant of a matrix can be calculated. So let's take an example. Example number 1. Find the determinant. Find the determinant of matrix A when matrix A is equal to 1, 7, 5, 6. You remember what type of matrix is this? This is 2 by 2 matrix, and we can also call it a squared matrix. So when we have a squared matrix, or we have 2 by 2 matrix, how do we find the determinant? The determinant will be as solved below. Determinant of a matrix should be represented with this symbol. Can you see it now? This 2 slash on the matrix name, matrix A. So this becomes the determinant. So we will tell this sign to be determinant of a matrix equal to. Now what do? What we do is to multiply the element diagonal. Multiply the element diagonal and then subtract one diagonal from the other one. So how do we get started? This is the first element. We say element A11. A11 meaning matrix A, the element of matrix A in row 1 and column 1. So this A11 will be multiplied with A22. This is A22. So 6, then subtracted as minus, then A12 will be subtracted from A21. So this will be 7 multiplied by 5. So 1 multiplied by 6, we have a 6, minus 7 multiplied by 5, we have a 35. So 6 minus 35 gives minus 29. So minus 29 is the determinant of this matrix. Now let's take example number 2. Example number 2. Let's find another way that matrix can be changed. So let's take matrix B to be 3 minus 2 minus 3 and 2. Now when you look at this matrix, we still have square matrix, but there's something new about the square matrix that we need to learn. So let's see. To find the determinant of matrix B, what we do is to find the solution and just following the process that we took at the other time. So matrix B determinant is equal to, we take B11, multiply it by B22, that's 2, in bracket, then subtract B12 and B21. So open another bracket. This is carrying a negative, so you must take it with the sign. Minus 2 multiplied by, this is minus 3, so you must carry them with that sign, minus 3. So 3 times 2 gives 6, minus, open bracket, 1, this is minus 2 multiplied by minus 3. Minus times minus gives plus, correct? And 2 times 3 gives 6. So this is 6 in bracket. 6 minus 6 gives us 0. So 6 minus 6 gives us 0. Now, any matrix whose determinant is 0 is called a singular matrix. It's called a singular matrix. So this matrix is called singular matrix. Singular matrix. So what about the first one we did, whose determinant is not 0, greater than 0? That one we call it non-singular matrix. Non-singular matrix. So I believe you should be able to differentiate between singular matrix, non-singular matrix, and determinant of a matrix by now. So to just find the determinant of a matrix, you multiply the elements at the diagonal and then subtract it by the elements multiplied together at the other diagonal. This works for matrix of the same row and the same column, let's say squared matrix or matrix 2 by 2. What happens when we have matrix that is not 2 by 2 yet a squared matrix? Let's take example number 3. Example number 3 says, find the determinant of matrix C